What's going on, guys? It's Bucky and welcome to your ninth chemistry tutorial. And in this tutorial, I'm going to be talking to you guys about something called the quantum mechanical model. Man, that just sounds fun already. So anyways, what chemists did was, once they started looking at really complex atoms, they tried to take the model that Bohr came up with and they tried to apply it to these really complex atoms, and they found out that it didn't really fit. It didn't really make sense. So instead, they said, okay, Bohr, your model's good for the more simple atoms and elements, but for this complex stuff, we need a complex equation, hence the quantum mechanical model. Let's go ahead and dive right into it. So basically what the quantum mechanical model is it's this formula, I guess you could say, pretty much a way that chemists can predict how electrons spin around the nucleus. They figured out that it's instead of simple circular orbits like Bohr said, they actually spin around the nucleus in this very complex 3D paths, and you really need a bunch of different numbers other than, you know, orbit number one, orbit number two. You really need a bunch of different variables in order to figure out just exactly and calculate the path that those electrons take. So those numbers are n, which stands for the orbital's energy, L, which stands for the orbital shape, ML, which is the orientation or how it's tilted, MS, which pretty much means is your electron spinning clockwise or counterclockwise. And with those four numbers, you can go ahead and calculate a formula to figure out a really complex 3D path. And this isn't like any random, this is actually one of the paths that electrons take. I just didn't make a weird 3D model and plug it in here. This is actually one of the quantum mechanical models. So this is the path that electrons take. Pretty weird, huh? A lot more complex than a simple circle. So let me go ahead and break apart these numbers, and once I break everything apart and put it back together, you're going to see how you can use these four variables to calculate the exact path that electrons take. Let's go ahead and touch on the first one, which is orbital's energy, or other words, n is the variable that they used. Now technically this n is called the principal quantum number. I just say orbital's energy because it just makes sense. It basically is the orbital's energy. They just had to put a scientific term on it. So what this means is it's pretty much the average distance of the orbital from the nucleus, or in other words, the average distance that the electron is from the nucleus. And it can be any whole number, 1, 2, 3, 4, exactly like Bohr's orbitals. You know how Bohr's orbitals were labeled 1, 2, 3, 4, and so on? It's the exact same thing with this n. And of course, the larger the number, the bigger the orbital is going to be, hence further away from the nucleus. So 1 orbital is really close to the nucleus, and 4 is really far away from the nucleus. So now that we understand n, let's go ahead and talk about L, the orbital's shape. So technically this one is called angular momentum quantum number, but I'm just going to go ahead and say L equals orbital's shape. So basically the value you can have for L is n minus 1. So say for example that your n value, let me just pick one, say your n was 4. Well, according to this equation, it can be n minus 1, so 4 minus 1 is 3. So L can be equal to 0, 1, 2, or 3. So that's what I mean. L equals n minus 1. Whatever your n is, take 1 away from it, and that's what values L can be. And you're saying, okay, how can one number represent a shape? That doesn't make sense to me. Well, basically what they did was they paired up a number with, and they just made them represent different shapes. For example, whenever you have 0, it represents kind of a sphere shape. Whenever you have 1, it kind of looks like two balloons are pressed together, and we'll look at the shapes later on. And this is a really complex one. Let's see, where is it? Right there. This is a really complex one. That isn't 0 or 1. It's one of the higher ones. I can't even remember just by looking at them. I need the graph with me. But anyways, that's what you come up with if you go deep enough. It's like Inception. So anyways, the different numbers just represent different shapes. So just remember right now that n equals the size of the orbital and L equals the shape of the orbital. Two numbers we learned so far. So already we came into kind of a problem. Whenever you're writing these numbers together, it's kind of confusing because you try to write them together and it doesn't really look easy. I mean, you can say, okay, 1 equals n, so 0 equals L, so I'm going to write 1, 0. No, that looks like a 10, and no, these all kind of look like 10. So how can I take two numbers, be able to write them together without getting it confused with a number like 10 or 32 or, 21 or something like that? So what scientists decided to do is, instead of keeping the number for L, they decided to give the L value a designated letter for each number. So whenever you have 0 for L, you write S instead. Whenever you have 1, you write P. So that way, instead of something like 1, 0, which may be confused with 10, you write 1S. So that solved the problem of having to write two numbers together. And if you write two numbers together, it just turns into a bigger number. So this right here solved that problem. So again, to sum up this entire tutorial, remember this. There are four numbers that you need to calculate the path of an electron. We learned two of them already. N, which is this first one, is the size of the orbital, and the second one, which is the L, is the shape of the orbital. So this 1s right here means the orbital is pretty small, and the S is a sphere, and we'll look at the shapes later. So this 1s is a small spherical shape. So we still got two more variables to cover, and in the next tutorial we're going to be covering those. And once we have all the variables, we can begin putting this quantum mechanical model together. And I just want to say this, guys. If you stuck with me and you're still listening to this video, probably this tutorial and the next tutorial are the two most complicated tutorials for a while. The quantum mechanical model is kind of new in chemistry relative to everything else, so it's kind of confusing subject, but once we get past this, then everything's going to start coming together and you're going to understand chemistry so much easier. So anyways, just stick with me for this tutorial, the next tutorial, and maybe the next one, and then it's going to be a breeze, I promise you. So anyways, thank you guys for watching. Don't forget to subscribe, and I will see you guys in the next tutorial.